Hello, modelers. My name is Frederick Senior, and I'm in a team together with Joseph Dumont, Richmond Silvanos Baye, and Emmanuel Brefo. We decided to work on an interesting topic titled Bacteria Soft Rot in a Storage. So, post-harvest loss is a big issue in the agriculture industry. About 1/3 of the world's food is lost after harvest. Bacteria soft rot is an infection that causes loss in potatoes. Once infected, or once infections happen, the potatoes get soft, rotten, and emit an awful smell. There are no varieties known to be resistant to soft rot. The bacteria enter tubers through wounds and small pores of the tuber. So as you can see on the slide, we have pictures of a potato that could have been a good meal. We modeled the spread of this rot through cellular automata. So the unit we considered was potato tubers, and we had 3 state variables: normal potatoes, infected potatoes, and rotten potatoes. And we only have 4 assumptions for our model. The first one is we are considering a closed system. The second, only immediate neighbors determine the outcome. Third assumption, potatoes are of the same strain. And finally, potatoes may only become rotten if they are infected. This is the diagram of our model. So each cell will have a normal potato, infected potato, whose rules are defined as follows. Rule number 1, if a normal potato has an infected or a rotten neighbor, then there is some probability, beta, that it becomes infected. Rule number 2, if an infected potato has a rotten neighbor, then there is some probability delta that it becomes rotten. Otherwise, that infected potato has some probability gamma of becoming rotten. So the methods we employed is 1, we considered 3 initial conditions. We had some small amount of infected potatoes placed at the center of our grid. And then we had another set of potatoes placed within the corner of a storage or in the corner of our grid. And then the last condition, which we considered, was some amount of infected potatoes that was scattered throughout the storage or throughout the grid. We simulated this in MATLAB, and we considered the following parameters: a probability beta of 0.05, gamma of 0.03, and delta of 0.07. After running our simulations in MATLAB, this is the graphs we got. So first, the yellow grid or the yellow color represents normal potatoes. The red ones represent infected potatoes. And then the black ones represent rotten potatoes. So in the first simulation, we place some group of potatoes at the center of our grid. So throughout some time step, we realize that the spread over time is being covered by black potatoes. In other words, rotten potatoes. And we can see the same strain, or we can see the same idea running through our 3 simulations. Conclusion. So we realize that based on our simulation, that the rate at which an entire storage, or in this case, a grid, becomes rotten is dependent on the location of initial infection, because we considered 3 conditions: center, corner, and random. For practical purposes, it will be best to position weaker potatoes at the corner of the storage. In other words, if you have scenarios where you have a weaker potatoes and you don't want to get rid of it, then it's best to place them at the edge rather than placing them at the center or randomly. Now, potential extensions to this model can be one, an addition of an exposure state to make it a 4-state model. We can also investigate parameter values. With this, we end our presentation, our small project. Thank you very much for your attention.